So we have to find the equation of the line that is passing through the point 210, parallel to the plane 3x minus y plus 3z equals 2, and perpendicular to the line x is equal to 2t, y is equal to 3 minus t, z is equal to t plus 2. It is in parametric form, of course. We can write it in symmetric form, not a big deal. We have information about the plane. We have information about the point that the line is passing through. We are missing one bit of information about the line. What is that bit? In terms of vectors. What do we need to know in order to describe a line in 3D space? That is for a vector, Caleb, or a line. Talia? We need to know the direction vector and one point. We need a point, we need a direction vector. If we have that, we know the line. Well, I've got a point. Do I have a direction vector? No. So what do we do? Any thoughts? While the thought is hopefully coming to your mind, the plane has to play a role in finding the answer. If you have to do anything with the plane, what do you need to know?
Can we find the normal vector to the plane and then find the orthogonal vector to the normal vector?
Okay, first we've got to find the normal vector of the plane. So what is the struggle that we have to go through to find the normal vector of the plane?
Look at the coefficients.
Look at the coefficients, easy struggle. So look, so tough. The normal vector, and assume it's full. 3i vector minus j vector plus 3k vector. And write it as 3 minus 1, 3. Good. Now I have another line. The line here is x is equal to 2t, y 3 minus t, z is equal to 3 plus, or t plus 2. If I want to know something about that line, we need, speaking vector language. We already had the answer from the previous one. Talia?
The direction vector.
Direction vector, okay. So what is the struggle that we have to go through to find the direction vector of that line?
Solve for t.
Solve for t, okay.
So wait, when you solve for t, each of the denominators will be the direction numbers.
Very good. So that is the struggle Chris is going to go through. Is that? I'm not even going to do that. I know the answer already, Jake.
We can just write it in parametric form.
It is in parametric form.
So we just write 2t, 3 minus t, and then t plus 2.
What? That is Jake's struggle. I know the answer
Can
already.
you just plug a number in for t and then?
Plug a number in for t. That is Chase's struggle.
T's coefficients are going to be the direction numbers.
Okay, struggle became less trouble. All you have to do is look at the coefficients of t. Do you agree? Because if you solve for t, 2 is going to be in the denominator. Agree? -1 is going to be in the denominator. 1 is going to be in the denominator. So I know the direction vector of the given line . To -1, +1. Good. I have a normal vector. I have the direction vector for the given line. I want to find the equation of the line that is parallel to this plane. So Chase, what did you say?
Gonna find the vector orthogonal to both those lines.
We have to find the vector that is orthogonal to these two. If you can't see it, yeah. That is my plane. Okay. I'll change it to a different picture. Yes, that is the normal vector n. And we have a line that is going somewhere, and it has to be, whatever line that we are trying to find has to be perpendicular to this line. Let's say we have a line of that sort. Good. And we want it to be parallel to this plane. So a vector that is orthogonal to this, yes. Somewhere here, it's going up there. Agreed. Is going to be parallel to its normal vector. Yes. Well, at the same time, it would be orthogonal to n. Yes. Orthogonal to the line to n. So how do we find that vector?
Take the cross product.
Take the cross product of
The two vectors.
the two vectors. Well, practice, give it a try. Good question though. Now, A cross B is not equal to B cross A. But the thing about normal vectors, doesn't matter where you put, the normal vector is always orthogonal to the plane. So you can change the direction, still have the same normal vector. This is a line that is going in 3D space. So whether it is here, there, doesn't matter, still a line that is going in space. All that matters is that it is orthogonal to the line. So this one, whether it's here or there, will be parallel to the normal vector. So at the end of the day, you will end up with the same equation. Cross product of those two, 3 minus I, J, K, I'll call this n cross D, 3 minus 1, 3, 2 minus 1, 1. I vector, minus 1, minus 1 times 3, minus 3, there's a negative in the middle, 3 minus 1, we get 2. Minus J vector, 3 times 1, 3, 2 times 3, 6, 3 minus 6, minus 3, plus K vector, minus 3, minus 2, but there is a minus in the middle, minus 3 plus 2, minus 1. So 2I vector plus 3J vector minus K vector. Good. So that cross product gives us a direction vector. Do we agree? And any scalar multiple of that is also a direction vector. So I know a point, I know a direction vector. good practice, find the parametric equation of that line that we're looking for. Line using the point, which is 2 minus 0, and its direction vector. Two, 3, minus 1.
So positive.
Yeah, it's +1
2, 1,
for the point.
Thank you. So the direction vector is simply -1, so we know a point, we know the direction vector, line is good. So we'll start with the symmetric equation, x minus x naught 2 divided by a, get 2, y minus y naught 1 divided by b, 3, y or z minus 0 divided by -1. They all equal to t. So we have the symmetric equation of the line, which means I can get a parametric equation by using each of the term equal to t. So x minus 2 would equal 2t, y minus 1 equals 3t, z minus 0 equals -t. Good. Z minus 0 is just z. Move this to the other side, x will be 2 plus 2t, y 1 plus 3t, z 0 minus t, and you can write this as x of t, y of t, z of t, any one. And that would equal 2 plus 2t, 1 plus 3t, minus t. Good to do this now because the next chapter deals with vector functions. Each of these is a function. Good, linear function, linear function, linear function. And we know we can trace out an entire function in 3D space by varying t. Do we have the correct answer? Yes. Why? When I plug in t equals 0, it should correspond to the point that you started with. And that point is done. And if you increase t, you're going to move away from the point. Same happens if you decrease the value of t. This way, by changing t, you get the entire line.